G'day everyone, how are you going? Today's video is on polar form of a complex number. You've probably seen some videos before. I've done a couple of them where we're looking at the a plus bi form, which is the rectangular form of a complex number. We're now going to move that into polar form. It's quite a simple little thing. It really is a neat, simple little thing. So if we've got this format, and here's an example of it, 3 plus 4i. Nothing special in that. We've got our real component, our imaginary component. Remembering this is our real axis, this is our imaginary axis. So you can see I've dotted that up right here. Okay, 3, 4. Pretty simple there, nothing big. But look at the red labels that I've put on. Couldn't we kind of express that in terms of an angle and a radius? An angle and a radius, because if this, see this kind of like a circle here, right, and we've stopped at this point here. We've got a radius and some angle starting from the horizontal x-axis, just like we do with all our angle kind of work. So let's work these out. Well, if I've got 3 plus 4i, think of this formula here. Hopefully you can already see what I'm doing here. I'm really just dropping this down. That would be 4 along there, and of course this is 3 here. Tan is opposite over adjacent. There we go. And this comes out to 53.1 degrees from memory. I did just do it before. 53.1 degrees would be the angle in here. In a similar way, and you can probably note I chose these numbers neatly, 3 and 4, Pythagoras' triplets. 3, 4, 5 triangle is going to mean that one's nice and easy. Radius is going to be equal to 5. So I've got a radius of 5 and an angle of 51.3 degrees. Or we could put that in radians as well, whichever you prefer. So in a plus bi format, we've got this one, we've got 3 plus 4i. But in r cis theta format, and I'll explain that cis part a little bit more, in r cis theta format, we've got 5 cis 53.1. Now again, in degrees, probably could have used radians and chosen some numbers that were going to work better. What does this cis idea mean? What's this about? Well, this is cos plus I sine. Cos plus I sine. So this part here becomes 5 lots of, come down here with me, 5 lots of cos of 53.1 degrees plus I sine of 53.1 degrees. Right, now let's look back in this triangle here. If I work out, if that's 53 degrees, let me get that one in. If that's 53 degrees, and I work out the cos of that one, isn't cos working out this one right here? Yeah. And if I work out the sine of that, isn't that working out this one right here? And then if I was to take that and multiply it by the radius, that would give me these lengths. If you're unsure about that, just work this out. You'll get some decimal, multiply it by 5, and you will get that one right there. Oh, sorry, that one right there. If you take this one, the sine of 53.1, and multiply that by 5, you will get this one right here. So really that idea of cis is really just a neat way of using two things, the radius and the angle, to give you the polar form of a complex number. So now this, we don't want to write this out every time, so we just write it neatly cis. So cis is just cos plus I sine. The radius hangs out the front, the angle hangs at the end, and we know that it's this. And of course the second part being with the I sine, the second part is going to be the vertical axis. The first part is going to be the horizontal axis, which relates directly back to our a plus bi. So the polar form of a complex number, you really just need to be able to use a bit of trig and a bit of Pythagoras, and you can write it. If you're given it like this, you've got to see it as being cos I sine, and realising that the cos of that angle multiplied by 5, that will give me the horizontal or the real component, and the sine of that angle multiplied by 5 will give me the vertical component or the imaginary component of that complex number. Now, you do want to be good at seeing that, understanding what it's telling you, and being able to convert between the two. But really converting between the two, as I say, it's a bit of trig and it's a bit of Pythagoras. You should be fine with that. Hope this video helped. Let me know if you want me to do a few examples and I'll get them up. Thank you.